Every time you log into your computer at work, access a shared folder, or send a document to the network printer, there's a hidden system watching your every move. It's a silent, ever-present gatekeeper, constantly deciding if you are who you say you are, and if you're allowed to do what you're trying to do. This system is the digital backbone for the overwhelming majority of the world's largest companies. It's the arbiter of trust, the enforcer of rules, and the single source of truth for the entire corporate network. For most people, it's completely invisible. A simple login box is the only clue that a massive, complex machine is working tirelessly in the background. But for anyone in IT, cybersecurity, or just curious about how modern corporations actually run, this system is everything. In this video, we're tearing down the wall between you and that system. We're going deep into the architecture and mechanics of the ultimate digital gatekeeper, Microsoft Active Directory. You'll learn not just what it is, but how it's built, how it thinks, and how it does its most important job, deciding in a fraction of a second who gets in and who stays out. By the end of this, typing your password will never feel the same again. The problem: a world before central control. To really get why Active Directory is such a big deal, we have to travel back in time to a much messier, more chaotic era of networking. Picture a small, growing business in the mid-90s. We'll call it Innovate Corporation. Innovate Corp starts with 5 employees. The IT admin, let's call her Jane, manages 5 computers. When a new employee, Bob, joins, Jane sets up his PC. She creates a local user account right on that machine. Bob sets a password, simple enough. But when Bob needs the company's shared files, which live on a different computer, Jane has to create another account for Bob on that server, with another password. When they get a new network printer, Jane has to set up access for Bob on the printer itself. That's 3 resources, 3 separate accounts, and potentially 3 different passwords that Bob has to remember and Jane has to manage. Now, Innovate Corp gets successful. They start growing. A year later, they have 50 employees. Jane is now wrangling 50 computers, a dozen servers for different departments, and a whole fleet of printers. The company hires a new accountant, Sarah. Jane has to walk over to Sarah's specific computer to create her local account. Then, she has to log into the accounting server to make an account for Sarah there. Then the general file server. Then the HR server. Then she has to manually add Sarah to the permission list for 3 different printers. A week later, Sarah forgets her password. Which one? Her PC password? The accounting software password? The HR server password? She has no idea. Jane now has to go reset the password on multiple systems. Now, imagine this problem scaled up for 50 employees. It's a complete nightmare. It's not just inefficient, it's a security disaster. Every computer is an island. Every server is its own little kingdom with its own list of citizens and its own set of rules. There's no central authority. To remove an employee who's left the company, Jane has to hunt down every single account on every machine and server that person touched and disable them one by one. If she misses even one, that ex-employee could walk over to a colleague's desk and potentially access sensitive company data. This was the reality. A world of digital anarchy, held together by spreadsheets, sticky notes, and the sheer willpower of overworked IT admins. This chaos is the exact problem Active Directory was built to solve. It was designed to take those thousands of isolated islands and unite them into a single, manageable continent. Introducing the solution: Active Directory. In 2000, alongside Windows 2000 Server, Microsoft rolled out its answer to this chaos: Active Directory. At its core, Active Directory, or AD, is a centralized database and a set of services that connect users with the network resources they need to do their jobs. Think of it as a company's phone book, its HR department, and its security force all rolled into one. The database, the directory itself, lists every single user, computer, printer, server, and shared folder on your network. In AD lingo, these are all called objects, but it's so much more than a list. For each of those objects, AD stores detailed information, or attributes. For a user object, that's their name, job title, phone number, and most importantly, their password, or technically a secure hash of it. For a printer object, it could be its physical location and who's allowed to use it. The services part of AD are the engines that use this database to control everything. The most important service is Active Directory Domain Services, or ADDS. This is the core engine that manages all the users and computers and lets administrators organize them into a logical hierarchy. The servers running ADDS are called domain controllers. They're the physical brains of the operation, the gatekeepers we talked about. So, back at Innovate Corp, instead of every computer being an island, they're all joined to a central Innovate Corp domain. When Sarah the accountant is hired, Jane doesn't touch her computer or any of the servers. She sits at her own desk, opens the Active Directory tools, and creates one single user account for Sarah in the central directory. From that single screen, Jane can define Sarah's entire digital life at the company. She sets her password. She adds her to a group called Accountants. And here's the magic. Because that accountants group has already been given permission to the accounting server and the finance printers, Sarah automatically gets all the access she needs. When Sarah logs into her computer, the PC doesn't check a local list anymore. It reaches out to a domain controller and asks, "Hey, someone named Sarah is trying to log in. Is she legit?" The domain controller checks its central database, verifies her password, and says, "Yep, she is. Let her in." From then on, every time Sarah tries to open a file on the accounting server, that server checks back with the domain controller to make sure she has permission. This is the power of centralization. One user, one identity, one password that unlocks all the resources they're allowed to use. It transforms chaos into order. It's why Active Directory became the bedrock of corporate IT for the next 2 decades and beyond. The big picture, the AD hierarchy. To manage a whole organization, from a small business to a global megacorp, Active Directory needs a way to organize everything. It can't just be one giant flat list. To solve this, AD uses a logical structure that's brilliant, but maybe a little confusing at first. The key is understanding the different levels: forests, trees, domains, and organizational units. Let's use an analogy. Imagine a massive global conglomerate called Global Tech Incorporated. The forest. At the very top is the forest. The forest is the entire organization, the absolute boundary of everything. For Global Tech Inc., the globaltech.com forest is the whole company. Every single user, computer, and resource belonging to Global Tech lives inside this forest. It's the ultimate security wall. By default, a user in one forest can't access anything in another. It's a digital fortress. The tree. Inside a forest, you can have one or more trees. A tree is a collection of one or more domains that share a contiguous namespace. Let's say Global Tech acquires a major subsidiary in Europe called Eurosystems. They could make eurosystems.com a separate domain. But what if they open a new branch in Asia? They could create asia.globaltech.com as another domain. Because asia.globaltech.com shares the globaltech.com root name, it forms a tree structure with the parent domain. Eurosystems.com, with its different name, would be a separate tree living happily inside the same forest. The big takeaway is that all domains within a single forest automatically trust each other. This transitive trust means a user in the Asia domain could, with the right permissions, use a printer in the main US domain without needing a separate login. The domain. The most fundamental building block is the domain. A domain is a group of network objects, users, computers, printers, that all share the same AD database. In our example, globaltech.com is a domain. It's the primary boundary for administration and applying rules. Every domain needs at least one, and preferably more, domain controllers. These are the servers holding a copy of that domain's database and handling all the login requests. When you log into your work computer, you're authenticating against a domain controller for your specific domain. A company might have multiple domains for a few reasons. Geography, they might have a us.globaltech.com domain and an emea.globaltech.com domain to keep network traffic local and apply different regional policies. Administration. Maybe they want a totally separate IT team to manage a specific division, so they give it its own domain. Security. A top-secret research division could be isolated in its own domain with much stricter password and access policies than the rest of the company. Organizational units, OUs. While all that is the macro structure, the real day-to-day work happens inside organizational units, or OUs. An OU is just a container within a domain that you use to organize objects. Think of them like folders and subfolders for your network. They are the secret weapon for taming complexity. Inside the us.globaltech.com domain, our admin, Jane, wouldn't just dump all 5,000 US employees into one giant list. She'd create a structure of OUs. She might create top-level OUs for sales, marketing, engineering, and finance. Inside the sales OU, she could create sub-OUs for North America sales and South America sales. Inside that, she could have OUs for sales managers, sales associates, and even computer OUs like sales laptops. Why bother with all this? Because OUs are where you apply specific policies and delegate control. This is one of AD's most powerful features. Jane can apply a policy to the sales OU that automatically maps a network drive to the sales folder. Everyone in that OU and its sub-OUs gets that drive. She can then apply a more specific policy just to the sales associates OU that blocks access to the control panel, while the sales managers are not restricted. This allows for incredibly fine-grained control. If the head of marketing wants to reset passwords for his own team, Jane doesn't give him control of the whole domain. She can delegate control to him for just the marketing OU. He can manage his own people without being able to touch anyone in finance or engineering. This whole structure, forests for security, trees for organization, domains for administration, and OUs for granular control, is what lets Active Directory scale from a 20-person business to a 500,000 employee enterprise, all within one logical system. The gatekeepers, domain controllers. So we've got the logical blueprint. Now let's talk about the physical engines that make it all run. These are the unsung heroes of the network, the powerful servers known as domain controllers, or DCs. A domain controller is simply a Windows server with the Active Directory Domain Services ADDS role installed. It's the brain and the muscle of a domain. You literally can't have a domain without at least one DC. Its job is complex and absolutely critical. First and foremost, a DC holds a copy of the Active Directory database. This file, technically called ntds.dit, is the crown jewels. It contains every object, every user, every password hash, and every group in the domain. It is the master record. Because this database is so critical, you never, ever have just one domain controller. Any real business will have at least two, and often many more. The reason is simple: redundancy and load balancing. If Jane resets a password on DC1, that change is automatically replicated to all other DCs in the domain. This multi-master replication keeps the directory consistent everywhere. It also means that if DC1 crashes or is taken offline for maintenance, the other DCs just pick up the slack. Users can still log in, access files, and the network keeps running without a hiccup. The main jobs of a domain controller really boil down to three things. Authentication. This is its most famous job. When you try to log in, the DC is responsible for checking your credentials against the database and giving a yes or no. We'll get into exactly how it does this next. Authorization. Once you're in, the DC's job isn't done. It also helps with authorization, deciding what you're allowed to do. When you try to open a file, the file server can ask the DC to check your group memberships to see if you have permission. Policy enforcement. As we saw with OUs, DCs are responsible for dishing out policies. These rules, called Group Policy Objects, GPOS, dictate everything from your desktop wallpaper to complex security settings. When you log in, your computer talks to a DC to pull down all the relevant policies and applies them. There's one more special job a DC can have: being a global catalog, GC. In a big forest with multiple domains, how do you find someone in a different domain? Searching every domain one by one would be painfully slow. The global catalog solves this. A DC that's also a GC holds a full copy of its own domain's database, plus a partial, read-only copy of every other domain in the forest. This partial copy has just enough info for searching, like usernames and email addresses. So when you search the company address book, you're almost certainly talking to a global catalog server. Because domain controllers hold the keys to the entire kingdom, they are the most critical servers on any network. Securing them is job number one. Attackers who get control of a DC have basically won. They own the network. This is why they're kept in secure server rooms, protected by firewalls and managed with extreme care. They are the digital gatekeepers. How it really works: authentication and authorization. Okay, we've covered the what and the why. Now for the main event, the how. When you type in your password and hit enter, what is actually happening to get you in? The process is a masterpiece of cryptography and networking, designed to be both secure and fast. The star of the show is an authentication protocol called Kerberos. Its main goal is to prove your identity without ever sending your actual password across the network. To get Kerberos, you just need to know the three main players: the client, your computer; the server, the resource you want to access, like a file server; the key distribution center, KDC, the trusted middleman. In Active Directory, the KDC service runs on every domain controller. The KDC itself has two parts: the authentication server, AS, and the ticket granting server, TGS. Think of the AS as the main gate of an amusement park where you first show your ID. The TGS is like the individual ride operator who gives you a specific ticket for each ride. Let's walk through the Kerberos handshake. Step 1. The AS request. You enter your username and password. Your computer doesn't send the password. Instead, it converts your password into a cryptographic key and uses it to encrypt the current time. It sends your username in plain text, plus this encrypted timestamp, to the authentication server, AS, on a domain controller. The message is basically, "Hi, I'm Bob. Here's proof I know Bob's password." Step 2. The AS reply and the ticket granting ticket, TGT. The AS looks up Bob in Active Directory and finds its own copy of your password's key. It uses that key to try and decrypt the timestamp you sent. If it works, and the time is recent, to prevent old stolen requests from being reused, the AS knows you have the right password. You've been authenticated, and your password never crossed the network. The AS now generates a special ticket called the ticket granting ticket, TGT. This is your master pass for the day. This TGT is then encrypted with a secret key that only the ticket granting server, TGS, knows. The AS sends this encrypted TGT back to your computer, along with a session key for this login, which is encrypted using your password key. Step 3. The TGS request. Your computer gets the reply. It uses your password key to decrypt the session key. It now has two things in memory: the TGT, which it can't read, and the session key. You are now officially logged into the domain. So, let's say you try to open a file on a server named FILESRV01. Your computer knows it needs another ticket for this. It creates a message for the ticket granting server, TGS, containing the TGT, the name of the server you want to access, and an authenticator message that it encrypts with the session key. Step 4. The TGS reply and the service ticket. The TGS gets the request. It decrypts the TGT with its own secret key to check it. Then it uses the session key, which it finds inside the TGT, to decrypt your authenticator. If everything checks out, the TGS is convinced you're legit. The TGS then issues a new specific ticket called a service ticket, just for accessing FILESRV01. This ticket is encrypted with the file server's secret key, which the server and the TGS both know. It sends this service ticket back to your computer. Step 5. Accessing the server. Your computer finally presents this service ticket to FILESRV01. The file server uses its own secret key to decrypt the ticket. If it works, it trusts that the ticket came from the TGS and that you are who you say you are. Access granted. This sounds incredibly complicated, but it happens in milliseconds. And the best part is, this process enables single sign-on, SSO. Once you have that first TGT, your computer can silently get new service tickets for your email server, internal websites, and databases, all without you ever typing your password again. Finally, remember the difference between authentication, proving who you are, and authorization, what you're allowed to do. Kerberos handles authentication. Once the file server knows it's you, it still has to check its access control list, or ACL, to see if your username or a group you're in, like accountants, has permission to open that folder. If yes, the folder opens. If not, you get that access denied message we all know and love. The power of centralization, why it matters. Okay, let's zoom back out. We've seen how AD brings order and how Kerberos provides secure logins. But the real power of Active Directory is in managing the entire environment from one place. The main tool for this is Group Policy. A Group Policy Object, GPO, is just a collection of settings that an admin can apply to users and computers. This is where those OUs we talked about become so critical. GPOs are linked to sites, domains, or most often, OUs. Back at Innovate Corp, Jane can create a GPO called Standard Desktop Settings and link it to the OU containing all employee computers. In that one GPO, she can configure hundreds of settings. Security, enforce complex passwords that expire every 90 days. Block USB drives to stop data leaks. Configure the Windows firewall on every single machine. Software, automatically deploy Microsoft Office to every computer. When a new version comes out, she just updates the GPO and everyone gets the upgrade. User environment, set the corporate logo as everyone's wallpaper. Automatically map the shared and department network drives so they just appear. Add the right printers automatically. When a computer starts up or a user logs in, it asks a domain controller, "What rules apply to me?" The DC looks at the user's and computer's OU, sends down all the linked GPOs, and the computer obediently configures itself. This is a complete game changer for IT. Instead of Jane running to 500 different computers to install software, she does it once, in one place. It guarantees consistency, boosts security, and saves an incredible amount of time, allowing a small IT team to manage a huge number of computers. This centralization is also what makes single sign-on possible. Because your one identity is trusted by a central authority, that trust can be extended to countless apps on the network. You log in once to Windows, and you're in. That seamless experience is a direct result of the trust model Active Directory provides. The true value is right in the name. It's an Active Directory. It's not a static list, it's a dynamic framework for command and control over the entire network. CTA. By the way, if you're getting value from this deep dive, do me a favor and hit that like button. It really helps the channel. And if you want more breakdowns of complex tech like this, make sure you subscribe so you don't miss what's next. The Active Directory family and its cloud evolution. While AD Domain Services is the king of on-premises networks, it's part of a larger family, and it has a modern, cloud-native cousin that's shaping the future of identity. Microsoft built a few other services around the core AD framework. Active Directory Certificate Services, ADCS, lets a company act as its own certificate authority to issue digital certificates for securing websites and encrypting files. Active Directory Federation Services, ADFS, helps extend your identity outside the company walls. It's what lets you use your work login to access a third-party app by creating a trust between the app and your company's AD. Active Directory Lightweight Directory Services, ADLDS, a stripped-down version of AD that applications can use without needing a full-blown domain. But the biggest change in the world of identity is the cloud. As companies adopted services like Microsoft 365, a new problem appeared. Traditional AD was built to manage things inside the corporate firewall, not for the internet-first world. To solve this, Microsoft created Azure Active Directory, recently renamed to Microsoft Entra ID. Now, here's a critical point. Entra ID is not just Active Directory running on a cloud server. It is a completely separate modern identity platform built from the ground up for the cloud. While traditional AD speaks Kerberos, Entra ID speaks modern web protocols like SAML and OAuth 2.0. While AD manages domain-joined Windows computers, Entra ID manages user identities for accessing cloud apps from any device, anywhere. It's the identity service for all of Microsoft's cloud, including Microsoft 365 and Azure. Today, most organizations live in a hybrid environment. They use a tool called Microsoft Entra Connect to synchronize their on-premises AD users up to Microsoft Entra ID. This gives them the best of both worlds. They can keep using traditional AD for their internal servers and computers, while giving users a single identity that works for both local resources and cloud apps. A user can log into their laptop with their AD password, and then seamlessly access Salesforce or Teams using that same identity, often secured by multi-factor authentication, MFA, managed by Entra ID. Understanding this difference is key for any IT pro today. ADDS is still the king of the on-premises kingdom, but Microsoft Entra ID is the future of identity, built for a world without network perimeters. Conclusion. So, let's bring it all home. We've seen that Active Directory was born to bring order to the chaos of early networks. It replaced digital anarchy with a centralized structure of forests, trees, domains, and OUs, creating a single source of truth for an entire company. We've met the silent sentinels of the network, the domain controllers that act as gatekeepers, authenticating users with the elegant dance of Kerberos, which secures your identity without ever putting your password at risk. And finally, we've seen how this central control, through the power of group policy, allows IT to manage thousands of systems from one screen, and how that legacy is evolving with its cloud successor, Microsoft Entra ID, to meet the challenges of the modern world. The next time you log in at work, just for a second, appreciate the incredible complexity working for you. That simple login box is the tip of a massive iceberg, a gateway to a hidden world of digital trust, policy, and control. It's not just a system, it's the foundation of the modern corporate network. It is Active Directory. Thank you for joining me on this deep dive. If you want to keep exploring the core components of IT, be sure to subscribe and hit the bell icon so you're notified when we release our next video. Until then, stay curious.